So now we've found out how to find the molar mass of a single element. We also know how to find the molar mass of a compound. What do we use these things for? Well, we use them to convert. We use them to find how many grams are in an amount of moles, or vice versa, how many moles are in a certain amount of grams. That way we can start to make some predictions about our reactions. But before we do, let's get some practice on what's needed and what's asked of us to do these conversions. So the first thing we need to do is find out what we're solving for when we're given a problem. Then we have to find out what is the thing that I need to convert. What am I being asked to do again? Place the number you want to convert out front over 1. So we're going back to kind of our ideas of how to do these conversions. Find the molar mass of that compound. So if the thing you want to convert is H2O, you have to find the molar mass of H2O. And then you're going to use that molar mass and set it up to cancel out the unit you don't want anymore. Then check your cancellations. Make sure that they cross out. Then you can finally calculate. So let's go through this. So I created this problem and I want to make sure that we're answering these 3 questions on our way to solving it. So how many moles are in 2.35 grams of H2O? So let's look at what we got here. So what am I solving for? What do I want to find? How many moles of H2O? That's what I want to find at the end of this whole thing. What do I have to convert? Well, if I look through, how many moles are in 2.35 grams? So I need to convert that 2.35 grams of H2O. And I do want you to write it out like that. I want you to tell me, what do these numbers mean? And then lastly, what is the molar mass? And I want to find the molar mass of H2O over here. So let's figure that out. So we go back to how we do this, right? We're going to draw a quick model of, we got our O, we got our 2 H's. I look on my periodic table. H is right here. That is 1.00794, and that's grams for every mole, which means I have another 1.00794 grams per mole. And then we got oxygen. Oxygen's over here. That's 15.9994 grams per mole. And we add these things together. So let's add these up. So we got 1.00794 plus 1.00794, we got plus 15.9994, which equals, and that's 18.0, we'll round it to 2. So that is 18.02 grams for every mole of H2O. Okay, so now we have our conversion, we have what we want to convert. So when we look back at what our flow chart is, we have everything we need. We found what we need to solve for. We found what we need to use to find it, right? What the value given is, so that's our 2.35 grams. We found the molar mass of that item. Now we got to set it up to cancel it out. So once we have that, find out what you have to convert, place it out front over 1. So we found out that we need to convert this 0.35 grams of H2O. Place that out front and over 1. Now the next thing that we were asked to do is to set up that molar mass to cancel out the unit we don't want. And I don't want grams anymore. So for every 18.02 grams of H2O, I have 1 mole of H2O, right? And our next step was to check to see if those things cancel. So grams of H2O cancel with grams of H2O. Now I can place this in my calculator and figure it out. So I do always go the long way, right? So 2.35 times 1 divided by 1 divided by 18.02, and that gives me 0.13, we can keep it there, moles of H2O. Now remember, I'm not putting grams of moles because I canceled out grams. Those are gone. I found just the moles, which is what I'm looking for here. So this is exactly what I want and how I want it recorded. So let's do one more of these together. So remember, so our flow, what are we trying to find? What do we have to find it? Place that out over 1. Find the molar mass of that compound. Set up to cancel those units, check our cancellations, and calculate it. So our first part here, what am I solving for? So let's read the question. How many grams are in 0.02 moles of BeI2? So grams of BeI2, so beryllium 2, right? So we're trying to find that first. Now, what do I need to convert? So how many grams are in that many moles? So I'm trying to convert this many moles. So 0.02 moles of BeI2. Okay. So let's put that out front because that's what I need to convert. So let's put that out front and over 1. So we got 0.02 moles of BeI2 out front over 1. Okay. Now I need to find what the molar mass is in order to do this conversion. So we have BeI2. So let's draw a quick model here. So I got 1 Be, and I have 2 I's. So I'm just going to draw an I there and an I there. Let's get going here. Okay. So let's see what we can find on here. So we got Be, beryllium, right up here. That ends up being, let's see, 9.01218 grams for every mole. And then let's see what our I is. So that's iodine. So way down over here. That is 126.905 grams for every mole of that. And then we also have the same thing over here, 126.905 grams for every mole of that as well. So let's add these things together. So we got 126.905 plus 126.905 plus 9.01218. And we add that all together, and we get 262.82 grams for every mole of BeI2. Okay, so now we have to use that conversion. So now I'm going to place that down here. So what am I trying to cancel out? I'm trying to cancel out moles. So the moles have to go on the bottom. So let's put our grams up first. So we got our 262.82 grams of BeI2. And then down on the bottom, that's for every 1 mole of BeI2. Okay. So now we're seeing how this is all set up. We realize that moles of BeI2 are going to cancel out with each other. So I'm going to be left with grams of BeI2. So let's put this in. So it's 0.02 times 262.82 divided by 1 equals, and it is 5.2, we'll round that up to 6 grams of BeI2. So that is our final answer. And that's why I like to really write out that phrase, because when you're done, your phrasing and everything will be telling me exactly what it is, how it relates, where it goes, and what to do with it. So I think if you have any other questions, please come and see me. Other than that, have a great day, and we'll see you soon.